Okay, so today we are going to talk about linear functions, and linear functions are, it's just an expression for a line. It's a mathematical representation for a line, but instead of the y equals mx plus b, it's now going to be f of x. That's what makes it a function. So that's what we're going to be dealing with, and just a few reminders. Most of this should be review. Just a few reminders. It's that m, that coefficient in front of the x, that represents the slope of the line. And then that b, that loose number or that constant there on the outside, is what represents the y-intercept of the line. So those are just some of the things that you got to remember. So let's just go through a couple of practice problems and see if we can remember how that works. So let's go ahead and graph one. Okay, so what if I were to give you a linear equation? I can give you a whole bunch of different ones, but let me give it to you as a function. So I'm going to give you a function f of x equals, let's say, 1/3 x minus 2. Okay, let's list out a few things that we know about it first. First of all, what is the slope of this line? And the slope of that line will be 1/3 because that's the coefficient in front of the x. And then, of course, the y-intercept. Y-intercepts are always given as a coordinate pair, 0, comma something. In this case, it would be 0, comma -2. So let's go ahead and plot those and see if we can get a graph out of that. It's always easier if you start with the y-intercept. So I'm just going to go down to the y-intercept of -2 and then do the slope after that. Excuse me. So the slope, because the slope is 1/3, it's rise over run, or if you'd like to think of it, it's the x values over the y values. Excuse me, backwards. It's the y values over the x values. It's rise over run. Let's write that actually down. So rise over run. So I have a 1/3 in this example. So I'm going to start at my y-intercept. I'm going to go up 1 and then over 3. And that's where I'm going to end up at because I went up 1 over 3. And that's what's going to connect that line. And that's how we graph that. Okay, so that's how you're graphing those linear equations. Another thing that I think would be worthwhile would be to talk about some of the fluke examples that happen. What are the fluke examples? So let's talk about just a few, maybe a little bit stranger ones. So let's think about this. If I were to give you a function f of x equals 7, okay, I have no x at all, which means this one has no coefficient in front of the x, which means it has no slope. So this is in fact a, oops, this is in fact, oh, sorry, let me start that over again. Okay, sorry about that. So because this has no x, what it really means is it means it has a 0 slope. So this is a slope of 0, which really means this is a horizontal line. Okay, and so for example, horizontal lines, what are those going to look like? If I were to do a quick sketch of here's my x and my y-axis, that horizontal line would be at the y value of 7, and it would just be that straight line. So that's what that means right there. A couple of other fluke examples then. What if I were to give you something that just simply said x equals 2? This one has no y, or no f of x, so this is the one that has no slope whatsoever, and in fact this is a vertical line. So if we were to try to graph that vertical line, this would be my x and my y. The way you would go ahead to graph that, you would just go to the x value of 2 and then draw that as a vertical line. Okay, a couple other things that I think would be worthwhile would be being able to actually find the slope given 2 points. So if I were to give you a question that said, find the slope of a line containing 2 points, and let's say the 2 points I'll give you are 1, -2, and let's say -3, 4. So I could graph that if we'd like, or we can go ahead and try to remember a couple of the formulas that we know about linear functions or lines. What's the formula for the slope? Remember, m was slope, and that was your y2 minus y1 over x2 minus x1. As I said, that's the y values over the x values, the change in y over the change in x. So you just have to pick a point to call your first point. So I'll pick this one to be my first point, so that'll be my x1 and y1, and then this will be my x2 and y2, and you use that information to go ahead and plug it into your slope formula. So this will be 4 minus -2, -3 minus 1, and then you simplify. 4 minus a -2, well, two negatives will turn into a positive, and that'll turn into a 6 over -4, which can reduce into a -3 halves. So that's how we find the slope of a line containing the 2 points. Ta-da!